Okay, let's unpack this. Think back. 75,000 years. Humanity, or what was left after the Toba supervolcano erupted. Well, we were barely hanging on.
It's a pretty stark reminder, isn't it? Earth can be dangerous, and let's be honest, we're pretty good at creating our own problems, too.
Definitely. And it's not just Earth, right? Remember that first exoplanet ever found? Orbiting a dead star back in '92? Talk about a cosmic warning sign.
Exactly. So the big question we're tackling in this deep dive is,
Right.
okay, what are the actual pathways for humanity? Not just surviving, but maybe even thriving out there beyond Earth.
Yeah, and what's really cool is how many different angles people are coming at this from.
Totally. You've got astronomers, physicists grappling with, the fundamental laws. You've got futurists.
And even sci-fi authors. Their imaginations play a role too. It's this huge mix of ideas about our long-term future.
Uh-huh. It's all part of figuring out how we stick around.
Right. So our mission today, for you listening, is to sift through all that. We want to pull out the really key stuff.
Give you a clear picture, yeah. The roadblocks, the potential breakthroughs for humanity becoming, well, a spacefaring species.
We'll touch on the tech, where we might actually go, and just what it really takes to make a home somewhere else in this massive, sometimes scary universe.
We're aiming for those aha moments, but without making your head spin too much.
Hopefully. So connecting this back to survival, the urgency to look beyond Earth feels pretty real.
It does. I mean, this isn't just hypothetical. Extinction events are a fact of Earth's history. Multiple big ones.
And now we've got our own modern threats stacking up. Climate change, obviously.
Right, yeah.
The risk of nuclear war. It hasn't gone away.
And then there's the really frightening stuff like engineered microbes. Some scenarios, like an airborne Ebola or something.
Yeah.
They predict wiping out like 98% of people. It's terrifying.
It really is. Plus, just the strain we're putting on the planet's resources, ecological Armageddon isn't just a sci-fi trope anymore.
But then you look up, and the number of planets we're finding out there, it's almost overwhelming. A bit of hope, maybe?
Definitely a counterbalance. Kepler, the ground-based telescopes, they've found thousands of exoplanets, planets around other stars.
And some are really intriguing. Remember that 2017 discovery?
Yes.
7 Earth-sized planets around one star.
Prep is one, yeah, just 39 light years away. And 3 of them are in the habitable zone.
Which means just the right distance from their star for liquid water, potentially. The Goldilocks zone.
Exactly. And then there's Proxima Centauri B, even closer, just over 4 light years, orbiting our nearest stellar neighbor.
The variety is stunning, too. The Extrasolar Planets Encyclopedia tracks them. You see systems with multiple suns, planets on crazy orbits.
Yeah.
It really makes you think habitable worlds might be, well, common.
And all these discoveries, they've definitely put some wind back in the sails of space travel, haven't they?
Oh, absolutely. It's a big contrast to the decades after Apollo. NASA did amazing things, obviously. But there was a period where it felt, well, a bit stuck.
Yeah.
The agency to nowhere, some called it.
Stuck in low Earth orbit, yeah. But now, wow, the private companies have jumped in.
Elon Musk, Richard Branson, Jeff Bezos, they're pouring in money and, frankly, a lot of passion. It's driven partly by profit, sure, but also seems like genuine childhood dreams of space for some of them.
It feels like a new space race. Definitely focused on Mars this time.
You've got NASA with its big SLS rocket and Orion capsule.
Right, and Musk with Starship, different approaches, different timelines, even different presidents pushing for Mars.
It's definitely heating up. Boeing's even said they want to be the first boots on Mars.
Competition, which might not be a bad thing in the long run.
Well, NASA's approach is understandably cautious, very safety-focused. They learned hard lessons from Challenger and Columbia.
Yeah, you can't forget those. And that whole faster, better, cheaper idea in the 90s didn't end well with the Mars Observer, did it?
No, it served as a reminder that you can't really cut corners in space. The stakes are just too high.
So beyond just getting to Mars, what about closer to home? The moon's getting a lot more attention again. A permanent base.
Yeah, and a big reason is resources, specifically water ice. They found quite a bit, especially in those permanently shadowed craters near the South Pole.
And water is gold in space, right? You can drink it, grow stuff.
And, crucially, split it into hydrogen and oxygen for rocket fuel. The moon could become a gas station for deeper space missions.
Makes sense. And besides fuel and water, tourism, science.
Definitely. Imagine low-gravity sports. Exploring would be easier. Plus those lava tubes. Huge underground caves formed by lava, not water, like on Earth.
Wow. Natural shelters, maybe? from radiation?
Potentially, yeah. They could be ideal spots for habitats, big enough to hold cities, some of them.
It really paints a picture like the moon as a staging post,
Yeah.
and then asteroids.
Asteroid mining, yeah. It sounds futuristic, but asteroids are packed with valuable minerals, leftovers from the solar system's formation.
So instead of cattle drives to Chicago,
You have resource hauls from asteroids heading to the moon, maybe. The moon becomes a processing center, the Chicago of space, refining materials to send to Earth or elsewhere.
that's a wild analogy, but I see it. And why are planets round but asteroids all lumpy?
It's all about gravity. Big things like planets have enough mass, enough gravity to pull themselves into a sphere. It's the most efficient shape.
Okay. Asteroids are just too small. Their gravity's too weak to smooth them out.
Exactly. They just keep their irregular sort of potato shapes.
So, okay, getting to these places, moon bases, asteroid mines, it all comes back to rockets. And the people who figured them out.
You have to start with Tsiolkovsky, right?
Yeah.
The Russian school teacher basically invented the theory of spaceflight from his desk.
Amazing. In poverty, mostly ignored. But he worked out the rocket equation, escape velocity, purely with math.
Incredible mind. And then you had Robert Goddard in the U.S., who actually built and flew the first liquid-fueled rockets.
He was inspired by Newton, wasn't he? Action, reaction.
Yeah, Newton's third law. Push mass out the back, the rocket goes forward, like letting go of a balloon. Goddard saw the potential, even if people laughed at him early on.
And then the less comfortable part of the history, the V2.
The German V2 rocket, yeah. Developed as a weapon based partly on Goddard's work, ironically, and after the war.
Its technology and its engineers like Wernher von Braun ended up kickstarting both the U.S. and Soviet space programs. Von Braun even worked with Disney later.
A complex legacy, for sure. But then Sputnik happened in '57.
The Sputnik shock. That really lit a fire under the U.S. They realized they were behind. I think I remember hearing about the Vanguard rocket blowing up right after very public failure.
Yeah, it showed the challenge.
Yeah.
But back to Newton for a second. His genius was seeing the universal connection. Apple falling, moon orbiting, same force.
Gravity. And he figured out orbital velocity, right? Go fast enough sideways, about 18,000 miles per hour, and you fall around the Earth instead of into it.
That's the core principle. Still is.
But even after Apollo, the public interest kind of faded, didn't it?
It did. The Vietnam War, issues at home, the huge cost was questioned. Should we send robots or people?
No Buck Rogers, no bucks, as that congressman said. People wanted human explorers.
It's a bit like that story of the Chinese Ming Dynasty, stopping their huge naval explorations. Focusing inward can have massive long-term effects.
Which brings us back to today and the private sector surge, especially Musk.
Yeah, his companies have a different philosophy, perhaps. More accepting of risk, seeing failures as learning steps. His goal is making us multiplanetary.
The Tony Stark comparison isn't totally crazy, I guess.
And this Mars race, Boeing is serious about getting there first, challenging SpaceX.
NASA's sort of in the middle, benefiting from this competition maybe, using these companies to achieve its own goals.
It's a fascinating dynamic.
Yeah.
But deep space travel, it's not a walk in the park. There are serious dangers.
Radiation, right. Outside Earth's magnetic shield.
Cosmic rays, yeah. Astronauts even report seeing flashes of light inside their eyes.
And the long-term effects. Recent studies suggest potential irreversible brain damage from deep space radiation.
Scary stuff. And solar flares. Big bursts from the sun. Huge danger. There was a massive one in '72, right between Apollo missions. Could have been lethal if astronauts were on the moon. Luckily, we can monitor the sun better now, get some warning.
Okay, so we need better ships. Ships that can get us there faster, safer. What about propulsion tech?
Well, ion engines are already used.
Yeah.
Very efficient, gentle push over a long time. Good for cargo, like the deep space transport concept.
Slow but steady wins the race, sometimes. What about faster? Laser sails.
Harnessing light pressure, a really old idea. Actually, Jules Verne, Tsiolkovsky mentioned it. You shine powerful lasers on a huge light sail.
Japan's Icaros mission showed solar sails work using sunlight, but lasers for interstellar. That's a huge power requirement.
Massive. And aiming them accurately over light years, huge challenges. Past attempts haven't quite panned out, though Icaros was a success.
Then there's the nuclear option.
Yeah.
Project Orion.
Yeah, setting off small nuclear bombs behind the ship. Huge thrust, but well, the fallout, the treaties, the potential misuse, highly controversial.
Even its designers had second thoughts, right? Ted Taylor.
He did. Then you have fusion rockets. Project Daedalus was a concept. Using mini H-bomb explosions or maybe contain fusion like in a tokamak.
Fusion power. The dream energy source. Still not quite there yet, even on Earth.
Exactly. Huge potential, but significant hurdles remain. And the ultimate theoretical engine, antimatter.
Antimatter annihilation, pure energy EMC squared.
The highest energy density possible. But making and storing antimatter, incredibly difficult and expensive. CERN makes tiny amounts of antihydrogen, but scaling up is a monumental task.
And then we get into the really sci-fi stuff. Warp drive.
Like the Alcubierre drive. Doesn't move the ship through space, but moves space around the ship. Creates a warp bubble.
Faster than light.
Theoretically. But it requires hypothetical stuff like negative matter or negative energy, like Jupiter's mass worth of it. Plus, how do you steer? Does it break causality? It's purely theoretical right now.
So even if we solve propulsion, we need to keep people alive out there for months, years. Weightlessness is a big one.
Huge issue. Bone loss, muscle decay. Astronauts have intense exercise routines. And the training. The vomit comet. Parabolic flights. Not fun.
No thanks. And the radiation we mentioned. Needs heavy shielding.
Definitely.
Yeah.
And for long-term bases, say on the moon or Mars, you need total self-sufficiency, closed-loop systems.
Factories, greenhouses, recycling everything, making oxygen, reliable power. Probably solar initially.
It's a massive undertaking. Think about Mars. People have dreamed of making it habitable for ages.
Those canals that Schiaparelli saw, right, which Lowell misinterpreted as artificial, led to all those stories of dying Martians.
Yeah, fascinating history. And movies like The Martian show just how tough it is to survive there, even temporarily.
So what makes Mars a candidate despite the challenges?
Well, its day length is similar to Earth's, about 24.5 hours, and it has an axial tilt, so it has seasons, kind of like us.
But the downsides are pretty major. Gravity is way lower, only 40% of Earth's.
It's freezing cold, average negative 127 Celsius. And the atmosphere is incredibly thin, almost no protection. Pressurized habitats and suits are essential.
So a permanent base, that's still a long way off, 2050 later.
Probably beyond 2050 for anything truly self-sustaining, yeah. It's a generational project.
But Martian sports would be amazing. Imagine basketball.
Higher jumps, longer throws.
Yeah.
Yeah, you'd have to redesign all the arenas. But the bigger dream is terraforming, making Mars Earth-like.
How would you even start?
Robert Zubin has detailed plans. Start with a base, use local resources, iron oxide, CO2 for plants become self-sufficient first, then, long-term, heat it up somehow.
Oh, how giant space mirrors.
That's one idea. Orbital mirrors or solar arrays focusing sunlight, or maybe import greenhouse gases like methane from Titan, or crash comets and asteroids into it for water and ammonia.
Crash comets into Mars, that sounds dramatic.
Very. NASA's even looked at concepts like the Mars Ecopoiesis test bed, seeding Mars with hardy microbes, extremophiles, to start changing the atmosphere.
And there's that wild idea that maybe DNA originated on Mars first when it was warmer and wetter and got blasted to Earth on meteorites.
It's speculative, but based on Mars likely having favorable conditions earlier than Earth did. Makes you think.
Comparing Earth, Venus, Mars, it's like three paths diverged, right?
They probably start out quite similar. Volcanoes, water vapor, all in the sun's habitable zone.
But Venus, runaway greenhouse. Carl Sagan figured that out, right? Too much CO2 trapped the heat.
Exactly. Cooked a planet. Mars, being smaller, cooled faster. Its core solidified, lost its magnetic field.
And the solar wind just stripped away its atmosphere and oceans over billions of years, leaving it cold and dry.
Shows how crucial size and a magnetic field are for long-term habitability. It's a delicate balance.
Which is why we're looking beyond planets, too. Moons like Europa and Enceladus.
Jupiter's Europa, Saturn's Enceladus. The big draw is those subsurface oceans. Huge amounts of liquid water hidden under ice shells.
Potential for life.
It's one of the best bits in the solar system. Enceladus even has geysers spraying water into space. Direct samples.
What keeps the water liquid way out there?
Tidal forces. The constant gravitational push and pull from their giant planets generates internal heat. Same forces shaped Saturn's rings, interacting with its moons.
Okay, what about Titan? Saturn's biggest moon. It has an atmosphere.
It does. Unique for a moon. Denser than Earth's, actually. Mostly nitrogen and methane.
But it's freezing cold, right? And dark.
Incredibly cold. Yeah, around negative 180 degrees C. Very little sunlight gets through, so terraforming seems unlikely. But colonization? Maybe. With massive enclosed habitats. Big challenges, though. No easy oxygen or CO2.
And then way, way out, the Oort cloud.
This giant sphere of comets surrounding the whole solar system, maybe halfway to Alpha Centauri.
A comet highway? Like stepping stones to other stars?
That's the far-out idea. Use comets as bases or refueling stops for robotic probes heading to other stars. Very long-term thinking.
Okay, so propulsion gets us there, habitats keep us alive. But who does the heavy lifting? Building stuff, mining.
Robots and AI seem like the obvious answer, eventually. Look at how fast AI is progressing. AlphaGo beating the world Go champion was a huge milestone.
So robots could do the dangerous, dull, dirty jobs. Construction, mining, maintenance.
Exactly. They overcome human limits, no need for bulky suits, they can handle harsh environments. But AI isn't human intelligence.
Right. The brain's not just a computer. Neural networks learn, but common sense, pattern recognition in new situations, social nuance, that's still hard for AI.
Very hard. So the idea of self-replicating machines, robots that build more robots in factories, that's a potential game changer for rapid expansion.
But also kind of scary, like self-aware robots?
That's the ultimate step, maybe. Exciting, but raises huge ethical questions. Fears of rebellion, you know, the tropes. And quantum computing could massively boost AI down the line.
So the timeline is probably better remote-controlled robots first.
Then more autonomous ones that learn. Then maybe self-replicating ones, conscious AI. That's likely much further off, if ever.
Looking even further, what about changing us? Human enhancement, transhumanism.
Biological immortality is one area. Caloric restriction extends animal lifespans. Research into telomeres, aging genes. Parabiosis experiments where old mice were rejuvenated by young blood.
Young blood. Seriously.
Yeah. A protein called GD-Evlan seemed key. If we could drastically extend lifespan, interstellar travel becomes more feasible. But think about overpopulation.
Good point. What about digital immortality? Uploading consciousness.
The Library of Souls idea. Mapping the brain's connections. The Human Connectome Project is working on that. Could we explore space as digital avatars? Hans Moravec suggested a way to maybe transfer consciousness seamlessly.
Whoa, is it still you, though? Big philosophical questions there.
Huge. Then you have cybernetics. Brain-computer interfaces letting paralyzed people move limbs.
I saw that. A guy kicked off a World Cup match using one.
Artificial retinas. Could they eventually give us supervision? Seeing infrared or ultraviolet, useful on alien worlds. Transhumanism is the broader idea, merging with tech to survive anywhere.
Do advanced aliens maybe do that? Become post-biological? Paul Davies suggests that.
It's one possibility. Or maybe maintaining baseline humanity is important, like in Asimov's Foundation series. Lots of debate there.
Which brings us to, are they out there? Aliens.
The big question. Speculation runs wild. Advanced civilizations building Dyson spheres to capture all their star's energy. That weirdly dimming star, KIC 8462852, caused a stir.
Tabby's star. Probably dust, but fun to imagine.
But the distances and timescales are just vast, communicating, let alone traveling, for civilizations millions of years ahead. It's hard to grasp, which leads to the Fermi paradox.
Where is everybody? If life's probable, why no contact?
Lots of possible answers. Maybe life is rare. Maybe civilizations destroy themselves. Maybe they're just not interested in us. Maybe their physics is totally different.
If we did meet them, what might they be like?
Well, likely descended from predators, maybe. Intelligence often arises from complex hunting or social strategies. Some kind of manipulator, like a hand or tentacle, seems likely for tool use.
And language, right, for passing knowledge down.
Essential. But the forms could be incredibly diverse. Intelligent octopods, smart birds, aquatic aliens using geothermal vents for energy.
What if their planet has natural barriers, like permanent clouds blocking the stars, or orbiting multiple suns like in Asimov's Nightfall?
It could completely change their science, their philosophy, everything.
Yeah.
And their motivations. Are they going to want our resources like in Wars of Worlds?
Mostly in steel, yeah.
Yeah.
Hopefully advanced civs have better options.
You'd hope so. Which brings us to the Kardashev scale, classifying civilizations by energy use.
Right. Type 0 is us, planetary energy. Type I uses the whole planet's energy. Type 2 uses the whole star's energy.
Maybe with Dyson spheres. We search for their waste heat, infrared signatures.
And Type 3, galactic scale energy. Black holes, maybe? Gravity wave communication?
Getting to Type I is a huge jump for us. We need to solve our own problems. First wars, sectarianism, self-destruction risks like biotech weapons. Space solar power could be a step towards Type I energy.
Type 2 civilizations. Harnessing their star. They'd be effectively immortal, right? Able to move planets, defend against asteroids.
Pretty much. And if humanity reached that stage across multiple stars, we might even diverge biologically over vast timescales, even traveling slower than light.
And Type 3, galactic power. Maybe uploading consciousness, sending connectomes across the galaxy at light speed to inhabit avatars.
Mind-boggling stuff. But even then, the speed of light seems like a hard limit.
Yeah.
Unless wormholes.
Needs exotic physics, Planck energy scales, string theory territory.
String theory tries to unite gravity and quantum mechanics. It might explain dark matter. Maybe it's particles like neutrinos. It's our best shot at a theory of everything, but still incomplete, unproven.
So even a Type 3 civilization faces the end of the universe, eventually.
Seems likely, based on current cosmology. The big freeze is the leading idea: universe expands, cools, entropy wins, heat death.
Or the big rip. Expansion accelerates and tears everything apart.
That's another possibility. Or maybe a big crunch, a reversal, though that looks less likely now. Our own sun becomes a white dwarf, then a dark dwarf. Milky Way crashes into Andromeda.
You're pressing. Is there any escape?
Freeman Dyson thought maybe you could adapt to an infinitely slowing universe. Or the multiverse.
Traveling between universes through wormholes. String theory suggests maybe a bubble bath of universes, each with different laws.
It's highly speculative physics, tied to inflation theory. The anthropic principle is another angle. Maybe our universe seems fine-tuned for us because we could only exist in one that is fine-tuned out of countless possibilities.
So we're the lucky ones in a cosmic lottery.
That's the idea. But understanding dark energy, the force speeding up expansion, that's key. String theory might offer clues. Maybe a Type Psi V civilization, if such a thing is possible, could manipulate space-time itself, escape the end.
Wow. Okay, bringing this all back down to Earth, kinda. We've covered a lot. Existential threats are real.
But so is that human drive to explore, to push outwards? Space travel tech is advancing, becoming more accessible?
Lots of different propulsion ideas, potential destinations. Living elsewhere won't be easy, but the possibilities are huge.
And the long term. Merging with tech, maybe even escaping the universe's fate. It's wild to contemplate.
So, to wrap up, we've seen these incredible challenges and potential futures. It really makes you think, doesn't it?
It leads to that final big question, maybe a bit unsettling. When you consider these vast timescales, the potential for transformation, for encountering the truly alien, what does humanity even mean?
Right. Are we defined by our biology? Or is our destiny something else, something we can't even imagine right now as we start looking out towards the cosmos?
It's definitely something to mull over. Are we sticking with this form, or are we heading towards something completely new?
A lot to think about indeed. We hope you, listening in, found this deep dive fascinating. There are so many concepts here: terraforming, warp drives, digital immortality, aliens worth exploring further.
Absolutely. Think about the ethics, the philosophy behind it all. The universe is out there, and honestly, our journey is just beginning.